Continuation of the next video, I want to express my math questions related solution related problem, that is the organic chemistry and the job guidelines. Now we wish to discuss the following problems, that is the stereochemistry related problems using the 2-alkyl ketone effect and the oxidation of the toluene to the aldehyde using the Etard reaction. What is the intermediate for that reactions, and this is the protection of the alcohol groups, and this is the one type of the cross coupling reactions using the nickel and chromium. Now we wish to discuss the following problems, that is the 2-alkyl ketone. What is the 2-alkyl ketone effect? 2-alkyl ketone effect means if the alkyl group is present at the equatorial position with the carbonyl group, then there is an steric interaction as the dihedral angle between that of the carbonyl oxygen and the alkyl R group is more or less is eclipsed in nature. So there is an steric interaction between that of the oxygens and the R group, and in the presence of the base it easily converted to that of the alkyl group present in the equatorial to axial position, and this is the unusual phenomena for the regular observation. We know that the large group in the equatorial position is more stable than that of the axial position, but in the presence of the carbonyl group this becomes reversed, that is the alkyl group comes to that of the axial position rather than that of the equatorial position, and this axial group equilibrium in the axial position is converted from this diagram. From this diagram it has been shows that if the R group sizes of the R group is increases, then there is the methyl, ethyl and isopropyl, then the 2-alkyl ketone effect becomes increased, and hence it is preferred to that of the axial position rather than that of the equatorial position. And this is the examples where the 2 methyl group present in the axial position, but after some equilibrium it becomes equatorial position, but this is unstable. Always the axial diaxial position methyl group is more stable compared to that of the diequatorial position. Similarly, if we see that of the tertiary butyl group, there is a large steric interaction, so it cannot be stable in the cyclohexane chair form, rather it present in the twist board form. This problem is giving on that basis, that is the lithium enolate and undergoes interaction, homology interaction with that of the alkyl iodide in presence of the base, that is the homo of the pi electron can interact with that of the methyl iodide and prefer to that of the axial position rather than the equatorial position. Hence the methyl group and the tertiary group butyl group is present in the trans orientation, and it is preferred to the axial orientation rather than that of the equatorial orientation. This is happened due to that of the 2-alkyl ketone effect. Next, if we see that of the X group on presence of the chlorine and bromine, we know that in case of the chlorine and the bromine, the axial orientation is more preferable compared to that of the equatorial orientation. This is nothing but if we see that of the Newman projection formula, in the Newman projection the carbonyl group and the X group present in the anti-orientation, this is less dipolar compared to that of the equatorial orientation. This is the more interaction with the dipole-dipole interaction, that is the negative charge on the oxygen atom and the X atom undergoes repulsion here. Next problem is the what is the result of this problem. From this problem it has been shown that the chair-like transition state and the major product is N, that is the methyl and the tertiary butyl group is in the anti-orientation, and the methyl group is preferable for the axial orientation compared to that of the equatorial orientation using the 2-alkyl ketone effect. Now we next problem, mechanism of the Etard reaction. In the mechanism of the Etard reaction, it has been shown that the toluene is converted to that of the aldehyde using the chromium chloride. We know that chromium chloride represented as a CrOO Cl2. and in this case the hydrogen is undergoes isomerization to produce the intermediate 2, and this intermediate 2 undergo pi electronic resonance followed by aromatization gives the p intermediate, that is the 3, and this p intermediate undergoes just hydrogen elimination to give the desired product aldehyde. And the problem is given that what is the intermediate for the formation of the toluene into benzaldehyde, and this problem the answer is the 2 is the, that is the 2 chlorine on the chlorochromium atom and the hydroxyl group, and the benzyloxy group is the intermediate for the Etard reaction. And this problem is similar to that of the, just like that of the PCC or PDC oxidation of the primary alcohol. We know that what is the structure of the PCC and PDC. In the PCC, the structure is that the nitrogen lone pair, the protonated form of the nitrogen lone pair of the pyridine, which undergoes salt pair with that of the chromate ions. In the case of the PDC, there is a dichromate ion. So this form is important due to the oxidation of the alcohol to ketone groups, and there is no side product for the alcohol to carboxylic acid. Here only the alcohol is converted to that of the ketone using the same type of intermediate, that is the oxygen lone pair is attacked and keep the chlorine groups, and then after that this hydrogen group is eliminated to give the carbonate. And similarly PDC also oxidizes the alcohol to aldehyde. Now we go to that of the alcohol protection chemistry. In the alcohol group can be protected using the different type of the protecting groups, that is the alcohol can be protected by dihydropyran, and alcohol protected by ethoxyethyl groups, and this is actually the vinyl ether. Vinyl ether and undergoes protected in presence of the alcohol. Alcohol can be protected by the vinyl ether, and the mom chloride can also be protected the alcohol group, and this is the similar type of the different type of the alcohol protecting group. And the problem is given is that the dihydropyran undergoes alcohol protection in presence of chiral alcohol. Here the chiral alcohol, the oxygen lone pair is attacked here and produces the OTHP intermediate. This is the OTHP. This is tetrahydropyran, and this is called as THP. And this tetrahydropyran can produces the both type of intermediate, as the pi bond can attack the alcohol group, oxygen lone pair can attack either in the top phase or in the bottom phase. In the top phase attack, it produces one isomer, and the bottom phase attack, it produces another isomer. But here the one stereo center is fixed here, and so suppose it becomes R and it becomes R, and it becomes S but it becomes R. So this two isomer is not enantiomer. This is a diastereomeric mixture. Since the one stereo center is already fixed here, so after the enantiomeric attack, it produces the diastereomeric mixture. And from this diastereomeric mixture, the answer for this problem is that a mixture of diastereomers. Next is the Najoki-Yama-Kisi reaction, and this is the cross-coupling reaction between that of the aldehyde in presence of the nickel 2 and chromium 2. Here the nickel 2 is first is the step is the reduction of the nickel 2 to nickel 0 using the chromium. Chromium 2 at first oxidized to chromium 3, and the nickel 2 is reduced to nickel 0. Then the nickel 0 undergoes oxidative addition with the alkyl halides or alkyl triplet. It undergoes oxidative addition to nickel 2 state, and after that the nickel 2 state undergoes transmetallation, produces the chromium 3 intermediate, and this chromium 3 intermediate undergoes reaction with that of the carbonyl group to give the desired product. And here is the problem is that the OTF undergoes oxidative addition in presence of the nickel 0 and produces nickel OTF, and then transmetallation produces the chromium 3 OTF, and then it undergoes addition with that aldehyde to give the desired product. This is the one type of that of the Bellis-Hillman type product. Here in case of the Bellis-Hillman, the electron withdrawing group present. The advantage for this cross coupling is that their electron donating group, that is the simple alkyl group, give the similar type of the product, that is the cross coupling product. So now in the next video we will discuss the following problems, that is the pericyclic related problem. Thank you for watching the video.